How's it going? I can already see so many folks in the comment section. That's awesome. I saw the uploading. I haven't heard it yet, Yash, but I'm looking forward to now that you mention it. It seems very interesting. Hi, Ria. Welcome back. Welcome back, Jackson. I I am very impressed with such creative usernames. It becomes very difficult for me to pronounce. But hello to you too. And Salarmo is back. Akuma's here. I don't know if you've been here before, Kuma. I usually don't forget hackers who join me. But Ajaxon's here, T Mine is here, Manish is here. That's awesome, folks. Welcome back. Today is our final part in our electronics series, and y'all have done such an amazing job. I told you I was gonna compile, all your pictures, and I was doing that yesterday, and I was like, wow, these people already know so much, and today we're gonna actually build upon all of that. And good morning, Yash. Oh, it's all right. I appreciate the effort. I appreciate the thought. And it's okay. I'll get used to it. How do I pronounce it though? Is it Emomi? Emominu? Emominu? There we go. Got it. Emominu it is. I can deal with that. All right. Well, welcome back, folks. I'm going to give it another 3 minutes for people to trickle in because today we have a slightly lesser crowd, which is great because I always tell people this, especially when I take FPHs. The smaller the crowd, the more I can answer your questions. So no worries in that. But in case people are joining in, let's give them another couple of minutes. But until then, you can tell me how it's been so far. If you all have any feedback for me, I'm great at taking criticism, so you can just go to the feed. This was total waste of my time. I would rather you cover it like that. So we can totally do that next time. So how it's been so far, the pace, the way we've been it, because I've done the first stream I did exactly last year. It was so structured. Like I had a PPT and I followed the PPT down to the like T. But now I've become a little more unstructured. I just go with the flow. I have a list of topics I want to cover and I cover them as they come. Well, I just call you Yash anyway. You know that at this point, I'm usually very careful about hackers' privacies, so I don't call their name, especially if they have a username and especially if they mention, like. But Yash, it's like 404 not found. No, that's Yash. Like every time I see 404 in anywhere in the username, I'm like that has to be Yash. And Ria is saying, giving me a thumbs up. So I'm guessing you don't have feedback for me. But remember, Emily takes her feedback very carefully. So if there was anything that you would like to change to the stream, I know there'll be a survey form later, but you can also mention it on Discord, and you can of course send it to me. Right? Awesome. So let's get going. I'm gonna give you all another minute in case you all want to post something about the streams that have been. If you would like to change the pace, if you would like the topics to be covered differently. But today is gonna be fun because today I especially like today because we're gonna be covering a lot of concepts. But remember, the concepts I'm covering are very high level. Okay, so the more you read about them, like I'll cover stuff like what do you mean by ADC? I'll cover stuff like why there's something called analog pins and digital pins. But remember, I'm giving you the very basic information. There are entire books on those topics. So just keep your eyes out, keep observing. You learn more when you observe, and of course read more about the topics you find interesting or especially don't understand. Right, I'm always there to give you more explanation on the server and the FPHs when I stuff. But yeah, and I don't know if I'll be staffing next month, but I don't know if you all have heard GHW is going to be happening every month. So I don't know about my next month yet, but I'm already excited about it. So yeah, okay. So I don't see any feedback coming in, and I see a lot of more people have joined us already. So today there is no PPT. Today we're just going to quickly introduce the topic and introduce me for anyone who's joining us for the first time, and we'll dive right in. And we'll cover so many terms today. We're going to read data sheets, and I'll tell you how, I can't know all the data sheets either. So a lot of times I'm just going through it and Googling a lot of stuff on the go, right? So I see Jackson is going to share some of his links today. That is awesome, Jackson. Again, Jackson here is our, in-house pro at electronics. Jackson, if you want to join me on the stream, let me know. All right. I I was expecting more of an optimistic point of view from you, Yash. But yes, that is correct. There are lesser FPHs every month. But okay, folks, so let's dive in. In case you are new here, welcome to the stream. I love doing streams on electronics and IoT. I started around exactly a year ago with IoT, and I realized that maybe we should start a little from the basics. And this is beginners week, GHW, so it just fit in. I've been a coach for more than a year now, and I obviously love the job, and I love interacting with you hackers. My current full-time job, though, is as a community manager at Blues Wireless. Oh, that's alrighty, Jackson. I already complained about how I'm waking up exactly an hour before the stream, so you're good. You're good. This is at this point. This is for me, like going meeting my friends, like really close friends. I don't bother with it anymore. But if you want to come on the stream and don't turn on your camera, that's perfectly fine. That is actually very cool, Yash. I understand your lack of optimism there. But I'm sure you'll figure out something better sooner or later. All right. So, what we've been doing, in case you are joining us for the first time, is we've been learning some very, very basic electronics and building up circuits using those components, understanding very basic stuff like parallel, series, resistors. We looked at inductors and capacitors yesterday, the last thing we did. And if you all have questions regarding that, because I know that was a very, very overview of the components, let me know in the chat. We'll cover it again. And today we're going to start with microcontrollers. You know the challenge, right? First, we're going to talk about, I'm going to give you a very small definition of what microcontrollers are, how are they different from microprocessors. Then, I'm going to give you an analogy. Then, we're going to have a quick exercise about y'all coming up with analogies. All right. Then, you go around your house and find the things that might have a microcontroller in it and post it on Discord. All right. And then we'll start looking into building stuff with microcontrollers. I hope you have your Tinkercads open. If not, I'm putting in a link right now. Before that, again, if you all are joining us for the first time, y'all are here and y'all deserve to be praised for that. You deserve a pat on your back for that. So make sure you register and check in so that you can get the bonus swag for attending all those extra sessions that you are attending. So let me quickly show you the process of registering and checking in. Let me just quickly find my link. There's my link. Open, share screen, Chrome tab. There we go. So this is the link. I'm going to post the link in the chat as well. All right. Wrong link. My bad, folks. Let's see. Let me get the right link. There we go. All right. So that's the link. This is the link. If you click on this link, this is what should open up. When you do, make sure make sure you're signed in here. Like you can see, I'm signed in here. And all I'm going to do is click on register and check in. As soon as I do, you click on join event, it will take you to twitch.mlh. As you can see the link popping up here. Awesome. And as soon as you do that, you're checked in and you are ready to win that bonus swag. All right, so make sure you check in. Okay. All right, moving on. What are microcontrollers? Keep those questions coming. Any feedback, again, very, very welcome. Okay, because this is the first time I'm experimenting with this content too. All right. So, what are microcontrollers? Anyone want to take a shot at it? What's the first thing that comes to your head when I say the word microcontrollers? The first thing that you think of. Every time I think of a microcontroller, everyone mentions a microcontroller, in my head, a washing machine pops up. All right, because that's how the first person who taught me, or mentioned microcontrollers to me, taught me what microcontrollers mean. So when you hear the word micro, it can be anything. It can be a device. It can be a person. It can be an MLH stream, as some of you have mentioned. What pops into your head when someone mentions microcontrollers? No one? Nothing? Is my internet down again? Let's see. Arduino. That's an amazing answer, Zaim. A mini computer, maybe that's another great association phrase. Raspberry Pi. That is a great point. We'll cover that. I am so glad you're enjoying the session at 6 a.m., Ruxan, but I wouldn't mind if you want to go back and sleep. I just complained in the first stream how I am a very, very late riser. So, my Twitch says that I am on stream. I honestly thought I lost internet for a bit. Sure, Ayush, let me send you the check-in link again. Hey, Jackson, that is absolutely right. Low cost computer on a chip. You're getting there. But again, it does not have to be an answer. It is what you think of it, right? There is no correct or wrong. It's your association, it's your intuition. And what we're going to do is we're going to build upon that intuition because you already know the answer basically. When you have some association made, you already know the answer. We're just going to, tune out the information out of it and, make sure you know the right answer to the actual question. So this is another great answer. It's an association. I especially loved the a mini computer maybe association. Like when someone says microcontroller, I'm like, okay, tiny computer. Great, great, great intuitive answer. Hey, Abhay, welcome back. All right, folks, no more answers. No worries. We can continue. So okay, now I'm going to tell you the definition of microcontrollers. I'll give you my analogy. Analogy is something that you would use to explain to someone that does not come from an electronics or a tech background, right? So it's like if I were to explain a microcontroller, I'll get to that. I'll give you an analogy. Oh, it's not? It is. It is the check-in link, Ayush. When you click on it, you can click on register and check-in and you'll check in. Are you looking for the Google form by any chance? Let me know. All right, then I'll go around searching for the Google form and get back to you. Uh, anyway, right? So what does a microcontroller do? Well, a microcontroller is basically any of your embedded systems. I shared the wrong link. My bad. I was taking it from the Excel sheet. I'm so sorry. Thank you so much, Ayush. I really appreciate that. Let me share it again so it goes on all the places we're streaming. Thank you for. No, did I share it the wrong both the times? No, the first time I shared it right, the second time I shared it wrong. All right, no worries. Okay, so thank you, Ayush. All right. So every time, right, any embedded system that you have, say it's your laptop. Now, laptop might be a little out there as an example, but it's okay for you to get started as an understanding, right? Washing machines, water purifiers, TVs, anything that's a device, right, and has an embedded system inside it, right? Something that's helping it, make some very simple logical decisions has a microcontroller, right? Another very good way of knowing whether it's a microcontroller is by knowing how the process is working. Are there any timed processes? I'll get to that in a bit because some of you all mentioned Raspberry Pi, and Raspberry Pi is not a microcontroller. Raspberry Pi is a microprocessor. Rather, it's an SBC, a single board computer. Microcontrollers aren't exactly computers. Uh, a very good way to look at a device and say whether it has a microcontroller or a processor, although in right now I would agree that the line is blurred, like when we spoke about electronics and electrical engineering. The same happens to this also, but how would you know it's in a microcontroller is whether it has you know a program running over and over again, right? Okay, so I'll give you an example. Your computer, for example, right? You click on it, it does not know where you're going to click it, right? You can just switch tabs, you can open whatever program you want, and it just handles tasks as they come, right? It does not know that that this is going to happen next, hence I'll be prepared for this. A microcontroller runs the same program over and over again. All right, that's how you know it's a microcontroller. For example, right, there's something. So how do you know that a microcontroller runs an RTOS, which is a real-time operating system? A microprocessor almost always runs a GPOS, which is a general purpose operating system, right? So an RTOS is basically things are timed. So in your washing machine, right, an example, your washing machine knows that when it's set in this mode, it's gonna, let the water pour in for 5 minutes. It's gonna let the spinning run for 20 minutes. Then it's gonna do, and it's the same thing over and over again in that mode, right? You can't just randomly go, okay, I'm just gonna turn off the valve and let the water and the washing machine will adjust the water. No, it can't do that. It's not that intelligent, right? It needs that much water. Now, as we go ahead in time, the controllers get smarter, right? So now you have sensors to check if that work was done or not. So if there's not enough water, it won't go on to the next task. It will keep waiting for enough water. But the point is, it won't be able to, okay, I'll just ask I'll just give a message that, okay, remove clothes, I'll make do with whatever water I have. It can't do that, right? So that's how a washing machine has a microcontroller, because it has something, one program that's running over and over again. It has different modes and logical settings, but it can't make decisions on its own. Or you can't just go and okay, say, okay, I'll just change the mode now, or things like that, right? Unlike a GPOS, in which you can just decide what you want to be able to do next. And I see chat. Yes, the sessions are recorded and they stay on YouTube. I know YouTube changed some setting recently. So you need to go in the live. So there are tabs, right? So there's videos and then there's live. And when you go in live, and you can see the previous videos that were streamed live and have been saved on the channel. If you can't find it, Filza, let me know. I will show it to you. All right, I'm just going to keep my YouTube tab open in case you need me to show it to you. I know what, I will show it. Uh, I don't want to forget. There we go. So I'm gonna search for the MLH channel. Right, StreamYard, add stream. There you go. So this is your MLH channel. You go here, you can see that this one's going on live right now. And when you go in live, right here, you can see that the last so you can see that there's a 14 hours gap here, right? The thing is, YouTube takes times to process and post it. So 14 hours ago, that means you will be able to see electronics part 2 right here. And you'll be able to see electronics part 1. There we go, over here, right? Filza, I am going to pick up this link that I have right now on YouTube and send it, so that in case anyone had trouble finding recordings, and YouTube does take time to process. So if you want to watch a recording that happened like 20 minutes ago or an hour ago, go to Twitch. But the thing is, Twitch removes the recordings in 90 days. So eventually, if you want to find videos, go on YouTube. But immediately, YouTube takes around 8 to 9 hours of buffer to process and put the video back into the channel. Oh yeah, so Twitch it's available, but the thing is, I never use it for referencing or sharing. If I want to share my link, I'll never put Twitch, because Twitch removes it in 90 days. So that's our subscription, right? In 90 days, we get rid of all the older videos. It expires basically. I'm glad I could help Filza. So it's a system you learn, dhire dhire, right? All right, let's move on. So now we all understand what's a microcontroller, right? At least you have a basic understanding, which is good enough for me, right? Because we'll look into a data sheet right now. We'll actually start building with it. Okay. All right. So now is the activity time. First, it's 10:54 in my clock. I'm gonna give us until 11 to give analogies, right? How would you explain? So how would I explain a microcontroller to someone? Is those toys that have just one thing every time you press a button? That's basically it, right? So a microcontroller is like that toy. But those toys, that laptop toys which have multiple things that they can do, that's a processor. That's how I would explain it to a 5-year-old, right? The difference between a microcontroller and a microprocessor. Your turn. I want good analogies. Think of shows, think of sports, think of anything that comes to your head and associate what we just learned. No one? Come on, folks. I always expect some good answers from y'all. Y'all have been so creative the past 2 days. It's really blown my mind. I'm still waiting for your answers. Come on, folks. I know you all are very creative. Is my internet again gone? I'm always so scared of losing my internet. Nope. My internet seems to be fine. And I see an answer come in. I like this example. See, this is what I mean. Oh God. Uh, okay, not something I encourage. Stereotyping anyone, but see, that's a funny association. I like that. This is a good way. It's a slightly complicated way, I would say, but I like the complex association in your head. That's what I'm looking for. Oh God, I okay, Abhay, I love the analogy. I'll give you that. It's very funny, which is why I like it. But we're not stereotyping people. Okay, fun. This is what I mean. See, that's what I mean by creative. I know you all are very creative. So another 3 minutes, folks. You all have wasted half your time. Come on, think of something. Think of funny. Just put it out. You can keep giving me analogies. You have to give me at least one, not minimum, maximum one. Come on, get this analogies running. Hi, you know what? I'm gonna get Mary to put out an analogy challenge next time in their post. I want to really see what y'all do there. No one, and I'm very sad. It's okay. I really appreciate Abhay and Jackson for trying though. Anyway, so let's move on. If y'all don't want to, y'all can keep it coming in later also whenever you think of it. Okay, no time limit on that. But okay, let's move on. Next is my favorite part, and I know you all enjoyed a little too. I wanted to go around your house and click a picture of something that might have a microcontroller in it. And we'll see if it has a microcontroller or a microprocessor or none of those. There are electronics devices which do not need a microcontroller to do some simple things, right? I don't get the reference here, Jackson. Yes, Abhay, I have a lot of faith that you'll win it too. But you never know, people might surprise us in the chat right now. Okay, folks, come on, go around the house. Remember, you want to post it on Discord Beginners Lounge Week. In case you do not know, I already tagged that channel in the announcement that I made today. So just go to the announcements channel of Global Hack Week, find the channel that I want you to post it in. Anything that you think might use a microcontroller, and then we'll see if it actually uses a microcontroller or not. It's 10:59 in my clock. I'm going to give you all till 11:05 to do that. Jackson, I still don't get this reference. I'm trying to think if there's something I missed. Okay. I don't see anyone typing. People have been slow today. I'm a little upset by the response today. No one's posting, no one's trying to find. Are you all trying to find at least? It's okay. Take your time. You can think about the objects around you. I'll start giving out hints in another 2 minutes in case you all can't think of it. Sure, freeze. So the channel name is Beginners Week Lounge. How do I tag you? I can tag you there. Can you tell me your Discord ID? I can tag you there. Or if you go in the announcements channel, I've tagged that channel there as well. All right, Abhay has posted his speaker's picture. That is awesome, Abhay. Awesome. So that's one picture, and I love it. And I love that thinking. Yes, a speaker could be using a microcontroller. We will figure out whether or not it does in a bit. But I just mentioned Raspberry Pi is not a microcontroller, Yash. Hmm. Yes, Abhay, I saw. That's awesome. And there's a TV remote. That is another great example. It's in poster. Thank you very much. I don't know, Abhay. Was that you before with the speaker or the remote? You're talking about Pi Zero. I'm not so sure, but we'll look into the data sheet. You're talking about Pico. Yes, a Raspberry Pi Pico is a microcontroller. Correct. Zero onwards is a processor. I remembered. I actually have a couple of Picos lying around with me. They also released a Pico's W now, which has Wi-Fi support. And I'm looking at the channel. This is Freeze. Okay, thank you, Simposter, for tagging you. And I'm but okay, at least some of y'all are going around trying to find. But Yash is also trying to find a speaker, which is great. But again, it's okay if you don't give me a picture of the microcontroller itself. It can be a device that uses a microcontroller. So you can go ahead, take a picture of your washing machine. I just mentioned that that is definitely a microcontroller, or your water purifier, or your refrigerator. All of these, right? I mean, refrigerator depends on how smart of a refrigerator you have, but basically, like the basic point remains the same. It has one program it's running over and over again, and it has scheduled tasks. You know what? I'm happy with the engagement anyway. I'm so glad so many of y'all at least tried to find it. That's okay. If y'all can't find it, and you can always keep it coming. I'll be making a collage of that later. All right. Let's dive into the actual circuits now. Okay, now I need you all to go into Tinkercad. We will start looking into different devices that are called microcontrollers, and we will start making things like yesterday. And there you go, Tinkercad. Posting the link again in case someone's new and does not know where to find it. Whenever you all are all on the same page and Tinkercad, let me know. We can get started. I'm going to share my screen till then. In case you all are joining us for the first time, we made some very interesting circuits the last few streams. So if you want to follow them and you send their picture later, I'll definitely go ahead and look at it. So in case you're sharing the picture later, do tag me. All right, folks, I'm waiting for heads up for everyone to be on Tinkercad. Hmm, today's been a little slow. And we all are ready. And I see comment. Present. All right. I'm glad you're already on your Tinkercad. That's great. I see Jackson typing. Go ahead, Jackson. And right after that, we will start looking into building our own project today. So we will actually use a microcontroller, get a sensor input, and connect it to an output. It can be anything. A motor. Awesome. And mommy know is ready as well. Oh, microcontroller inside. I like the example. This is an analogy and example all in one, say Jackson. I like the thought. Awesome. So let's get started, right? So in case you all missed yesterday, what we did was yesterday we actually went around classifying a lot of components as active and passive. Today we will directly jump into all and then scroll down into our microcontrollers. So you can see there are four microcontrollers here, right? There's Arduino Uno, there's microbit, there's microbit with breakout. We'll explain what the difference here is, and there's then something called a tiny controller. How cool is that? Awesome, Freeze is ready as well, right? So let me quickly pull out the most basic controller that you'll see a lot of folks use, right? So I'm gonna pull out an Arduino, keep it right here. Okay, so we're gonna name it Arduino breakout board. I'll tell you why I put the name breakout, because we're actually going to sit down, look at all the pins, see what they mean, and really understand what's happening here. All right, so let's go. Right, so you can see a lot of things on the Arduino, right? There are so many black dots, and there are these uh, random silver things. There's so many numbering. For some reason they've also decided to randomly put dashes and waves in front of numbers. The designers weren't thinking much, were they? Yes, so I am of course being sarcastic. Don't worry. I know I almost know the answers to most of the things I'm talking about. But yeah, so these silver things, these weird caps, and these random numbering with really not very aesthetic, right? Why? Why have they actually bothered through that, and why do people buy it anyway, right? Tinkercad is amazing. Yes, Yash. I'm recently discovering that too, because I usually don't like things that aren't open source, but Tinkercad is actually pretty great. There is no Pi Zero. But today, after we do Arduino for a bit, I will introduce you all to Wokwi. I think I did that last stream also. Was it September? Did I do that in September? And yeah, Wokwi. That's exactly the spelling without the extra I at the last, Yash. So they have yes, they have ESP32, ESP8266, and a couple of other. I don't remember whether they have a Pi Pico yet, but yeah, they have some more controllers than just Arduino. That is a great way to put it. All right. So why is the controller like this? What is this big black thing which is making it look so weird in the middle? So let's start with the big black thing, right? Here's what we're gonna do. What is the one instruction that I gave that you have to do when you see anything new, especially if you know it's gonna run with a battery? Right? If it's gonna run with a battery, that means it's some kind of an electronic device or an electronic component. And if you don't know or you're looking at it for the first time, what do you Google? What do you always first thing you Google? You do not Google how to, how the tutorials. You do not Google videos. There's one specific thing that you Google when you come across a new electronic component. What is it? Come on, if you all are joining the stream for the third time, you all should know what is the one thing I'll Google, even if I know what the controller does, and keep it ready with me to refer to. I'm gonna share a new tab and hope you all guess it before I have to tell the answer. Right, so I'm going to go to google.com. You can see what I'm typing. Right, this is my Google. And got it, thanks. And right here, I'm going to search for Arduino Uno. Yes, yes, the mysterious, Mysterian answered it. I'm sorry, I could not pronounce the last part of your username. But yes, datasheet. Datasheet is what you could know the component inside out. You could have worked with it a million times, but you always keep the datasheet open. The question was, Yash, what do you first look up when you come across a component or a board that you know or you do not know? If you're working with it, what is the one thing you Google and keep ready with you when you're working with a device? Exactly. So over here, you can see there are two data sheets. Which one would I ideally go for? The docs.arduino. Why? Because that's the official company of Uno. All right. So I'm going to quickly open this. And we're going to start going over this. So see, this is the color is different, but the idea over here is basically the same. And somehow this looks, I mean, to me it looks a little more cooler with all the tracks, but similar thing, right? Similar to what we just saw in the Tinkercad thing. So what is this black big thing right in the middle? The board looks fine otherwise. Why did they bother with that? No worries, yeah, Shine. I know you all know the answers. You all are just being a little quiet today, which I appreciate anyway. All right. So what is that big black thing? Funnily enough, right? Arduino Uno is not actually a microcontroller. Arduino Uno is a development kit for the microcontroller. The actual microcontroller is just this black thing. All right. So you can see over here it says Atmega 328P. That's the actual microcontroller. What Arduino has done is it's taken the microcontroller, all right? So the microcontroller has a lot of capabilities, right? And based on your application, you can pull out those capabilities with different components, right? For example, they'll say that this pin can do this and process this if you connect this and this component like that. Okay, so what Arduino has done is it's taken out its basic capabilities and again, it's a development kit. Yash. And how can you tell whether it's a development kit or a microcontroller? By the chip. So the microcontroller will always be a tiny chip, right? So if you see your products, right, they use a microcontroller, but they never have these pins and they never have this fancy layout, right? Because they use the microcontroller and they only take out what is necessary for their product. For example, if you're using Uno only to get one sensor input and an output for a product, right? For a product that's going to be manufactured, you're not going to use an Arduino board. You'll just take the black thing, the black ugly thing in the middle, and just take out those two components. Use only the things that you need, say a couple of resistors, maybe one voltage regulator, and only use that much because remember you're reducing the manufacturing costs. You're using only what's necessary, right? A microcontroller has a lot of capabilities, more than the Arduino is giving you even, right? So what you're doing is you're actually just using the microcontroller when you're making the product. So what a company ideally does is, if they know that this is the processor or controller that they want to use, they'll search for its development kit or evaluation kit, right? Those are the two terms called for used for this thing. They'll use a development kit or an evaluation kit to first, make proof of concept, right? Once they have the proof of concept, when they prototype, they won't use the evaluation kit anymore. They will order just the chips of the microcontroller, make their own PCB, right? Make their own kit, you can say, and use it in their product. So the size, the components, the value of the components will be very, very specific to their use case. Makes sense, everyone? Did that make a lot of sense? So how am I going to tell? How am I going to prove this to you all? Well, over here you can see, right? They've mentioned a lot of things, right? So this is the processor. Now remember, it is a microcontroller, but it's being referred to the processor as in the processor of that board, and it's not a microprocessor still. Okay, that's when they refer to the processor, what they mean is that's the brain of the board. Okay, Exactly, Yash. It's exactly like this. You know how React and all of them have these example things, right? So let's say if you want to test a button, you just clone the repo and you start using the button and play around with the button. Once you're sure about it, then you use that button code in your entire code. That's exactly what it is. That's an amazing analogy. Good job. Good job. All right. So yeah, learning with analogies is always so much fun. It's always so much better for you all to remember and relate with. But all right, so there we go. So now they have given us the processor. What I'm going to do is I'm going to go to a new tab now, and I'm also going to search for the data sheet of the processor itself. Right. So I'm going to share this tab. Right. I'm going to go ahead open the microchip data sheet. And there we go. So this is our Atmega 328P 8-bit AVR microcontroller. Remember, this is a microcontroller. The reason it's being called a processor in this sheet is because it's the brain of the board. That's why it's the processor. But remember, it actually is a microcontroller. All right, never get confused with that. Oh, Kaustub's back. Hi, Kaustub. All right. Kaustub, if you need me to catch you up, let me know. We haven't done much. We're just looking at data sheets right now. Okay. Okay, great. Let's get started. So now you can see there's tons of things that they've said, right? They've said that it's our advanced risk architecture. What's risk? Anyone? What's risk? It's reduced instruction set computer. All right. So that's advanced risk architecture. Then there is, its capabilities again. And remember, this is the summary of the entire chip. Okay. Great. So they've mentioned this. There are 23 programmable IO lines. There are These are the packages. What are packages? Remember, I told you that every controller, every component comes in different shapes and sizes according to your application. So these are packages, right? So a chip can come in this form, this form, this form, any form. It depends on the manufacturer and the application of it. So I'll tell you what they're saying, right? So they are saying over here that it comes in a TQFP package and a QFN 32 pad QFN package. So let me see if I can show it to you right here. There we go. So I don't know how clear this is going to be, but if you see, this is the QFP package, right? This is the QFP package. And what's the next thing that they're saying? A QFN package. Let's see if there's a QFN package here. Hmm. Hmm. I don't see a QFN package on this PCB ruler, but QFP again. But yeah, basically there are different kinds of packages and you can see them all on a size sheet. This is a PCB ruler, but you can always see it on different size sheets. Usually these companies, when they send you a sample or when you ask them from a business point of view, what they do is they basically send you this entire reference book with actual components of those size so that you can reference them in your designs when you're making your actual PCB. Okay, awesome. So let's move on. Okay, so now we know that this is the operating voltage. We know that Uno goes till 5 volts now. This is the speed grade. So we know that it can go up to 8 megahertz when we have 2.7 volts to 5.5 volts, and it can go up to 16 megahertz from 4.5 volts to 5.5 volts. These are the temperature ranges that it will function in. Then there's power consumption. Power consumption is a very important factor, especially when you're designing for wearables or anything that's going to use a battery, because your microcontroller cannot drain every 2 hours, and you can't expect a customer to charge your thing every 2 hours, right? Excuse me, right? So that's a thing. Okay, there we go. This is the QFP package. Then I don't see the QFN package yet, but okay. We get the point, right? Awesome. So now we have the pin descriptions. Now let's go back to our Arduino sheet and see what they say about the same thing, right? So this is our Arduino chip data sheet. It says this is the processor. Great. It's mentioned AVR. It's mentioned memory capabilities. Then it's mentioned security. Now it's mentioned peripherals, right? Remember, it does not, our other sheet just said 23 input output pins, right? They haven't done that. They've actually gone on to say how many pins do what, right? So they're saying there are two 8-bit timer counters. There's one 16-bit counter. There's one USART with fractional word product generator. A lot of new terms. Just keep absorbing the new terms, and whenever you're like, okay, too many new terms, we'll sit down, we just break down all the terms till then. Okay. Okay. Then they're saying dual mode controller. I2C something, it means something. We'll come back to it later. An analog comparator, remember this. Then there are timers, there are 6 PWM channels, interrupt, great. They are saying that this is the microcontroller being used. So now they've explained the processor, right? They said that there's an Mega 328 processor, which is basically an 8-bit AVR microcontroller. Great. Okay, done. Now let's look at the actual pinout, right? There we go. So see, this is a slightly more colorful data sheet than the Atmega 328P, right? Their pin description was much, much more boring, right? So this is what they described, and this is so much more boring, right? You know what? I'm actually just looking at if I have the right pin reference. Hmm. It is correct, but okay. We'll look into that data, right? So look at this data sheet that they're explaining. They've explained the block diagram of the entire AVR CPU, right? These are the gates. This is where the watchdog timer is. What is connected to what, etc., etc. Right? As we move on, there are resources. There are code examples. Then we have something called the block diagram of the AVR architecture, right? So where is the data bus connected? Which is the main line that's connecting? Great. Then they've explained the different registers, right? Can anyone tell me what's a register? Anyone? What's a register? Come on, folks. You all give me an example of a register being a passive component in the first stream. No one? Awesome. Awesome. I love the examples here. And I love the on and off. Exactly. It's basically good job. You're right? So basically it stores values, right? A register literally is like storing one of the smallest set of data holding places in a anything, right? This applies to both microcontrollers and register memory. Exactly. Now you all are associating things, which is awesome, right? So great job. Right. So these basically are these really quick, they're basically semiconductors, okay? And they have this quick on and off ability, and they're able to transfer and store data very fast. Exactly. Amazing, Abhay. Great job. Right. So what happens is in a microcontroller everything is stored in registers, right? Now when your entire how does your entire communication in a embedded system work, right? It's basically your registers of the controller talking to the registers of a sensor, right? So I mean there are tons of libraries and tons of resources available to make your projects right now, but whoever sat down and made the first library, right, actually sat down, read this data sheet, and then made a code. Okay, so first I need to, you know, go make a function to go talk to this register, request this data from this register. If the data in this register is this, that means this is the, answer, or this is what I'm looking for, or this is what I need to, give back to the user, right? So these registers is something you'll find in every data sheet. Every sensor data sheet will have, okay, this register stores this. If this is the number in the register, that means this is what the sensor is trying to do. That is how you know that there is error in the sensor, right? If you have these error codes, it's because the data sheet manufacturers have pre-coded this, right? And your your firmware engineer is actually just sat down, read the data sheet, and made an entire library that is fetching that code and also displaying to you, okay, this is what the sensor is trying to do right now, right? Awesome. So there are specific bits which mean something in every register. So if I wanted to check what is the status of the AVR, I'll go I'll go and try and read from this, right? This entire register. Every bit is going to tell me something, and based on my entire structure, I will know what is the AVR register is trying to do. And this applies for everything. Right now that they have mentioned all this in depth, like crazy depth on this data sheet, right? There's a reason this data sheet is so huge, you can see, right? They have explained everything that this possibly to do with the chip, right? So remember, this is the data sheet of your microcontroller, the actual controller. Your Uno is an evaluation kit, which is why it has, what it has done is, it it took the actual controller sheet, the microcontroller sheet, decided, okay, these are the things that we want the user to be able to do, and they've taken out that, made you a new board, and then told you what the board does, and not the entire capability of the microcontroller. So because we're going to be making with Uno today, we look at the Uno's data sheet because we want the higher level data sheet. What we will do is we look at all the components on the microcontroller and see what they try to do. Okay. All right. So this is great, right? You can see there's an LED built in. These are pins which have lots of numbers on them. There are lots of colors. So let's go on and see what that means. Okay. So NC, let's start with one, right? Let's go over every pin that you can see. So I think I'll go back to Tinkercad. I'll start sharing and we just go over the pins. Okay, everyone. What is GND? What's ground? What do they mean when they say ground? I know you all know the answer to that. Okay. What do they mean when they say ground? This pin that I'm hovering over. Let me just use this a little bit. There we go. So this is what I'm talking about. What is ground? Neutral. That is one way to look at it. Yes, that is one way to look at it. But what a thing that is a good, exactly. Ground is basically negative, right? Uh BCC power. So yes. So remember when we connected something to a battery, we connected the positive end and the negative end. Ground is not negative as much as it is, the reference voltage. What you're trying to do is, that's the lower voltage. Any components that you connect together, make sure that all their grounds are shorted, all the grounds. So let's say you connect the Arduino to a sensor, and then you're connecting the sensor to something else. You need to make sure that even the Arduino and the other things grounds are in short, right? Why? Because that's your reference voltage, right? Remember, when you are measuring something on the Arduino and it says 2 volts, it's not really 2 volts. It's not 0 and 2 volts. What's happening is the ground, it's 2 volts from the ground. Now the ground can be at any voltage. Ideally 0, yes, but it does not have to be. There can be noise, there can be, power coming in from the other sensor that's generating. So your ground is basically your reference voltage, basically the negative, the lower voltage, and hence the negative end of the positive part. So your VCC is where the power is coming in and the ground is where it's sinking. But remember, your ground is the reference voltage, which is why if you're working with multiple components, you always want to short their grounds, because if the reference voltages aren't the same, there can be an error in the sensor value. All right. I like people sharing their experiences here. That is awesome. I'm so glad to see this. But did that make sense, folks? Right? So your ground is basically the lower voltage. Remember what I said? The lower voltage always has the darker wire. So if I wanted to connect something to ground, or if I'm ever connecting something to ground, I always use the wire in black. Remember, that's good practices. All right. Great. So my ground, I can see how many grounds. One, two, three. Okay. So that's grounds. Funny story. If you ever want to create a ground or a VCC on your board, you can always create the other pins into VCC and ground. How? Because remember, your ground is not negative, it's the zero reference voltage, right? It's basically what we're saying, that this is the point it starts. So you can set a pin to low and you can actually connect it as ground, and vice versa for VCC. You can set the pin to high and let the, because what is high and low, right? We'll just get into that in a bit, right? So what is high and low? But remember what I just said, and then we'll connect. Okay. Awesome. I just love understanding microcontrollers or explaining them. It's just I just find them so cool, right? All right, let's go. Okay, so now we know all the grounds. Now you can see that there are these pins and then the random designs in front of pins. The designer wasn't thinking much, or was not in much of a mood to design. Well, no, the designer did not really design those waves. It's the electronics engineers who told them that no, put a wave there. What does the tilde mean there? Right. So the tilde over here means that it is capable of giving PWM. Okay. Hold on to that word. I'll explain it in a bit. I'll actually explain it on a Jamboard, draw you graphs and stuff. Okay. Then there's something called A012345. But I just had 012345 here. What the designer just felt like giving. I don't guess get it, Yash. What was it roughly for? Okay, I not sure. Oh, you thought that tilde was for roughly. No, 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 no. No, it wasn't. I figured it a minute later. But okay. No, no, no. The tilde means that those pins are capable of giving PWN. Okay, that's the electronics engineers telling that make sure that the people know that that is something different. Okay. Then these designers went ahead and added an A in front of 5 pins. What were they thinking? Well, again, the designers weren't thinking. It was the electronics engineers that said, okay, these pins are capable of taking analog input, right? So that is why they have that pin right there. Okay, analog in, exactly, analog input. Yes, Yash. Awesome. So now we know this is this. Okay, 3.3 volts, 5 volts, V in. Okay, all of these pins, all of them VCC, basically the higher voltage. 3.3 volt is going to give you a highest voltage of 3.3 volts, 5 volts, and V in will give you higher voltage of 5 volts. All right. Uh, oh, yes, it is written. My bad. It does say that. It does not say it on the actual Arduino though. I'm just gonna quickly check to see if I'm right or wrong. Uh, it does. That's awesome. So yeah, it does say analog in. True. True. Right. And it also says digital PWM and the reference right here, right? So you can see that as well. Awesome. Awesome. Yeah. I actually read it through the data sheets and not on the Arduino. So you learn the hard way, right? All right, moving on, right? So, okay, analog in, PWM, weird names, I don't know, too much to process. Then we have VN, VCC, that makes sense, right? We get 5 volts, 3 volts based on what's written on the pin. Ground clear. Now there's something called RxTx written here, right? On 0 and 1. Did they just feel like writing it? Maybe. We'll find out, right? So RxTx is receiving and transmitting. And you can see there are two registers here as well, right? There are LEDs actually right here. And there are two LEDs here as well that have RxTx on it. All right, so that's something. That's something that we need to look at. So what all we do we need to look at? Something called PWN, something called analog input, and what was the third thing? RxTx, right? And for some reason they've also given LEDs with the RxTx. Next, there are a lot of random components on the board, right? So, what are these? Why are they using these? So, okay, this is the USB in. That's a simple thing. Then there is the push button. Then there's an oscillator. Okay, oscillator. Anyone? Let's see. Where is the L in the LED? Oh, right here. That's a good question. Let's look into that. All right, we'll look into that. So the L in the LED is for the default LED. That is so they what they do is for you to be able to test out the code is they give you one LED on board which is connected to one of the pins. So if you make that pin high or you have anything connected on that uh, pin, if you make it high, even the LED will go high because they're shorted. Does that make sense, Hey Jackson? That is great. Exactly. That is why the oscillator is for, right? That's the clock signal that we're getting, right? Again, that is great association. That is what I mean when I ask you whenever I start a session. I'm like, okay, what is the first word that comes to your mind when you think of this? These are the answers I expect. But well, some at some point we got there, so we're good. Awesome. So we've covered oscillators. Oscillators is basically the signal that's, so remember I told you microcontroller works on a time, right? So it'll know that every 20 seconds, every this, so the oscillator is what gives it that oscillation signal for it, that frequency from which it can calculate time, right? All right. Awesome. Let's move on. Okay. So we now know what the L and the LED, this LLED is for. We know this is the LED which turns on when it's on. Then we know what this big black ugly thing is. We kind of know what the A is for and the wave is for. The rest of them, some of the numbers like 13, 12, 8, the designer didn't feel like designing them. Maybe we'll see why they have nothing, no other notation on it. And oh man, I need to learn to control this. Okay, better. What is this now? This is a voltage regulator. This is a MOSFET. Okay, so a MOSFET is basically a switch, a kind of a switch, and it's used for multiple purposes. I won't cover the MOSFET in detail right now because it's a beautiful topic. And if you all have the time, I would love for you all to explore transistors and MOSFETs in detail. But right now, we're not that concerned. What I do want to talk about is a voltage regulator, right? We we ran out of components to classify as active components yesterday, right? We had very few of them. So voltage regulator is actually one of them. It is actually an active component. So can anyone tell me what might the voltage regulator be doing? It's okay, take a time. You all can think about it. It is 11:38 in my clock. Let's give you all until 11:40 to give me answers. What do you think a voltage regulator is doing? Yes, regulate the voltage, but why? Like, I wanted an example from the board. Like, where is the voltage regulator? Where will you see? Not stabilize exactly. So, remember now, okay, you're giving the board one USB source of power, right? And with that, it's giving you 3.3 volts, 5 volts, a ground reference voltage. How is it getting so many voltages on the board? This is a good answer too, right? So it's giving stable voltage over temperature and battery voltage difference. That's fine. But what it's basically doing is it's enabling you to connect one single voltage source and give you multiple source of voltages, multiple sources of potential differences, new potential differences on the board, right? That is how you can connect a 5-volt sensor, a 3-volt sensor, let it, take power, give power, even sink the power into the board, and still not, fry the board. Because remember, there are so many components on the board, right? Exactly. So there's 3 volts. So your voltage regulator is your main source of power. That's where the power comes in. It's like, the guard. It's going to make sure that everything gets the right amount of voltages. Okay. It might not seem like much, but it's one of the most important components on a board, right? Because of the voltage regulators, some boards have certain different capabilities of voltages. For example, a pi does not have a lot of 5-volt pins. It has only a single 5-volt pin, and that's it. All of the rest operates on 3 volts. Arduino has mostly 5-volt pins except the 3.3 volts. So if you make any other pin high, it will ideally give you 5 volts. All right. Awesome. Let's move on into, now we're going to start looking into the pins. Okay. So let's take a quick 5-minute break. All right. A quick water break. It's 11:40 on my clock. We'll resume at 11:45. Until then, I would love for you all to start looking into what's ADC. Okay, if you all want, or you all can take a proper break, and we'll come back and see what is ADC and what's DC. Hi, Uptak, welcome back. It's okay, don't worry. We're still only halfway into it. We're gonna start learning about ADC, PWM, how the bits change, and things like that. Simple stuff. I've covered it before, and finally, we'll start connecting things to the microcontroller. All right. So 5-minute break. I'll see you all back here at 11:45. All right. All right, folks, we are ready to go. I hope you all quickly had some water, took a quick break, and are back refreshed. Thank you so much, Jackson, for sharing all the links. That is very sweet. Oh, there's an entire playlist with Tinkercad as well. That's awesome. All right. Great. So let's get into our board back again. So I said something about the wave and something about the analog in, right? What's the difference? Well, how does a signal really work, right? How does a sensor really work? So if you ever know, all right, I was just looking at the chart for a second, catching up with it a bit. Okay. So, how does a sensor really give you values, or how do you really get? So, your sensor is telling you, okay, the temperature is so and so degrees. What did it really tell your microcontroller, right? Or when we spoke about the infrared sensor the other day, how did it tell whether the contrast is there or not, whether it's white or black, right? So how do you know that? Well, the sensor is basically giving it voltage values. All right, your microcontroller is only capable of understanding voltage values. Okay, it can read and write voltages. That is it, right? So how does it give values and read values? Well, your sensor is obviously then giving back voltage values, right, that the microcontroller is reading, and then converting it for you into value, like into an actual temperature value, right? So how does that work? Well, there's something called analog values and digital values. All right, so yes, well, the data pin comes in when you have slightly more complicated, which we'll go on to the next, which is serial data, or SCL STA data when it comes to I2C, right? But before that, right, how is your, even if that's happening, how is it really understanding what's happening, right? So it's basically reading and writing voltages. So when it's reading the voltages, there are two ways that it can read it, right? It can either read it as an analog voltage or as a digital voltage. What's the difference between the two? Okay, so tell me the difference between analog and digital. Very basic difference, right? What's the difference between analog and digital? So in case y'all are still answering, go right ahead. I'll be looking at the chat. But digital is basically 0 and 1, right? Analog, on the other hand, is a number of values, right? So here's what I'm going to do. I'm going to quickly open a Jamboard for me. Okay. I'm going to quickly open a Jamboard for me. And I'm going to quickly draw some stuff for us, right? Great answers. I already see some amazing answers. So high and low, that's awesome. Analog is continuous voltage levels, that is perfect. Analog has different voltages. Amazing. Abhay Jackson, great answers, right? So how does your microcontroller know? You're getting there. You all are getting there. Amazing answer, Anish. Great work, Douglas. So great job, y'all. Y'all already know the answer, right? Y'all have a good intuition, understanding. Now we'll just tune it up, right? So let's look into our Jamboard, right? So I'm going to share this tab instead. All right, so we're going to look at signals for a bit. Okay? So, okay, let's look at the pen. Okay, so you know that digital is basically 0 and 1, right? Your analog, a good way to look at analog is a sine wave, right? So, a sine wave. Ah, you get the point, what, right? So, let's move on. So, now if you look at your microcontroller again very quickly, right? All the pins which have zero notations, which have no notations, are basically digital pins. They are only capable of reading and writing digital values. Okay. You can give it whatever voltage you want. It won't get spoiled, but it will only be able to detect 0 and 1. What does that mean? We'll look into it in a bit. All the pins that have these waves in front of them, the tilde in front of them, they are capable of reading digital values, but writing analog values, but not exactly analog values. They write something called a PWM. We'll look into what's the difference is. But the basic thing is they can write to analog sensors. Okay. For example, your motor speed has a lot of speeds, right? So it can control it using the number. Okay. Next, these analog pins are basically capable of giving or rather reading analog values. Okay. So that is the difference between the three pins. Okay. Now, what do you mean by reading analog values, writing PWM, and being able to do neither, and just reading and writing digital thing? So, okay, let's go back to our Jamboard. Okay, so let's go back to our Jamboard, and now we're looking at a graph, right? So my digital pin, right? A digital graph is usually shown with a square wave. If you ever look at a oscilloscope, it's actually 1, 2, 3, 4. So it's basically just the highs and the lows. These lines are basically only for understanding. Okay. So in an actual digital graph, these things don't exist, right? It's only the line in the middle and the highs and the lows. So how does that work? This is your, let's say, +5, and this is your reference ground, right? So this is the reference ground. Now, this does not necessarily have to be 0, but for the sake of, again, ideal thing, we're going to consider this as 0. So 0 to 5 volts, right? This is your middle line, remember? And this middle line is actually the most important line. Okay. Exactly, it just shows the change. That line is actually very, very insignificant and actually can be confusing. So always when you're imagining a square graph, just imagine the high, the low. Okay, so that's how it works. Now, the reason why I make the middle line very thick and, well, ugly now, but the point I'm trying to highlight is because that's the most important voltage. Your values, remember, the sensor can be giving analog values. How will it be able to detect digital? It will detect a digital like input output anyway, right? Like, it's going to detect a digital value. How it's going to know? Even if there's an analog voltage coming in, how will it know? Now, if it can only detect a digital high and a low, if it's +5 and 0, then it will, what should the value be? It'll go into error mode, right? But that never happens in your controller. It's, you either get a digital uh, value, or there's no connection, right? There's no in between where it's trying to gauge the value. It always has some value, right? So what it does is, how a controller works is, it takes the middle reference mean, right? Which, what would this be? It's basically 2.5 volts. So anything above the 2.5 volts will become digital 1. Anything below 2.5 volts will become a digital 0. This will apply to all the analog values. Let's say I put an analog sensor and it's giving me values in a wave, right? It's gonna keep reading values and keep giving me a 0 1 0 1 based on what it's reading. Funnily enough, this is exactly how a PWM works. Now, we know that there are analog input pins, which means we have something called an ADC on the Arduino, the analog to digital computer converter. What we do not have is a DAC. We do not have a digital analog converter. What we do have is something called a comparator, and what it does is basically, it it is something like that, the joke I tried to make in the first stream, right? It does not give you a analog value. What it does, it changes between 0 and 1 so high, and based on the frequency it changes, it gives you a analog output, and hence that analog output becomes a PWM, right? So it's basically switching between highs and lows so quickly that you get at a certain frequency, you get a value between 0 and 255. Does that make sense, folks? Let me know if it doesn't. Okay, so what happens is, it is going to give, the PWM basically will be I need to get myself a marker somehow. But okay, so PWM will basically be, right, this as an output, but you can control the frequency of this, right? And based on the frequency, your output, you can change it between 0 and 255. So here's an experiment for you all to try. Okay, you go on Wokvi or on this Tinkercad itself, okay, and write two functions. Okay, one will be analog out on this pin, and it will do the work for you. The next what you can do is you can make a for loop, not a for loop rather, a while loop, okay, and do while. And what you can do is in that you can go and change it to high and low. So you can write digital write high and digital write low, and you can put a timer difference in that, okay. And the speed of that, you can actually control the brightness of the LED, okay. I don't know if I'll be able to have the time to demonstrate to you today. If not, I'll put it on Discord, or we can do it tomorrow morning. I have a stream tomorrow as well. It's very different from electronics, but we'll just take 5 minutes to show that. Okay, so I hope you understood. So when you're doing basically a digital analog out, and or rather a PWM write on your Arduino, what you're basically doing is you're calling a loop, or you're calling the comparator, which is actually just writing the 0 and 1 so quickly. And based on how quickly it's writing, you can actually change the value, and hence you get a different PWM value. Isn't that cool? Isn't that very cool? All right, so that is your digital out in your Arduino, right? So that's your analog out. That's how you get your motor speeds, your LED brightness, and whatnot. Okay. The function to write in Arduino is also very simple. But what we're going to do next is we're going to understand how analog in works. This is actually another very cool concept, right? So basically, what analog in is doing is you have this wave, and it is obviously capable of reading all these values, right? But there's something called the ADC, right? Now, remember, it's all voltages, correct? So it can read some amount of voltage. Now, how does your voltage, analog voltage, get converted into numbers, or into sensor values that you can read? For example, there's something called the mapping function, okay, in your Arduino, that you'll always use if you're getting an analog input. When you're mapping it, what exactly are you mapping to? I'll give you a little hint, okay. In Arduino, you have to use the number 102 2 3, okay. So 0 to 1023 is what you map it to. Do you all know where that 1023 and 0 numbers came from? Why are we mapping it to 0 and 1023? Anyone? This is very cool. I promise you, you'll have fun when you understand this concept. Does 1024 remind you of anything? My bad. Is it binary for 8 bits? What's 2 to the power 10? This is a great answer. This is a great association, but I'm looking for a little different. 1024 values, exactly. What's 2 to the power 10? 1024. Do you know the bit value of the ADC in Arduino? Arduino has a 10-bit ADC. What that basically means is it's taking your voltage and converting, and it can read 2 to the power 10 fractions of that. So if you give it 3 volts, what it's going to do is it's going to split it into 1024 values. Then it will map the 0 to 1024 values to whatever you want. So let's say you're getting server, so you're trying to move a servo. It will map it at 1024 values to your servo 0 to 180 degrees. And every time you move, it's going to map that tiny fraction with the servo's movement. All right. That is how you know how good a microcontroller is in terms of its analog values. How will you know that? When you look at the data sheet, you'll go and see for the ADC. Right. So let me see if I can show you the Arduino's ADC. ADC and bit. Mm. Mm. It does not say it on this the datasheet that I have opened, but basically, if you look at the Arduino's ADC, it has a 10-bit ADC, right? I'm just trying to look at a good resource for you all to show it to you all. Let's see, 10-bit ADC. Mm, Give me 1 second, folks. All right, so did that make sense, everyone? I'm just trying to look at if I can show you the 10-bit ADC in the Arduino. I'm looking for a good image, but hmm. Mm-mm. All right, so I remember I told you Spark Fun folks are really nice and they actually make things very nice for us. So there you go. Right. So this is a good resource. I'm going to share the link to this for you all to read about it more a little later. But here you go. Right. So a 10-bit ADC, that's how the ADC works. But the idea behind that remains the same, right? So what it's doing is your highest voltage that it can read, which is basically 5 volts for Arduino or 3.3 volts for different microcontrollers. It takes that, right? 5 volts, that's the reference voltage. So it's reference to 5 volts, divides it by 1024. So that's your number of fractions. Then it takes whatever it's available, right? So 0 to 180 degrees says, and it maps it exactly. So for every one, change in the one or the change in 1 volt, so 1 volt will be what? 102, 5 volts divided by 1024 into 1, right? For every 1 volt, it will actually change the fraction of the servo. Isn't that cool? Isn't that very cool? All right. I am so glad we are through with some of the concepts for it. So now you'll understand the different pins in the Arduino. So let's very quickly, right, connect a sensor and what do you want to do? Do you all want to connect a potentiometer and change the brightness of the LED, or do you all want to run a motor? I think running a motor will be different, slightly difficult without a driver. So let's keep the component as LED. And what do you all want as sensors? Do you all want to or do you all want to take different? You all are welcome to do your own thing. So I'm just going to quickly reduce the size here, search for all components, look at everything that I have. I usually love controlling the brightness of the LED with the potentiometer. And the reason I take a potentiometer is I can show you how the whole mapping thing works, right? And let's search for an LED. All right. Are there any suggestions? Do you all want to do something different? Are you all following along? Oh, thank you so much, A Jackson. I like the generator that you all did. That you did. Thank you so much. That is amazing. Everyone, if you all what I was trying to tell you all like, about the LED blinking, A Jackson did an amazing thing with the signal generator, with the signal monitor, and that's awesome. That is absolutely brilliant. Thank you so much, Jackson. That is amazing. You know what? I'm actually going to share that image right now very quickly with you all. So this is what he did. So this is what I meant, right? It's not giving it a analog voltage. Rather, it's blinking it with highs and lows with a different frequency. Thank you so much, Jackson. Oh, that's because I didn't do anything. I was just trying to show the Arduino right now. Aptak is following along. That is awesome, folks. Okay, so let's then look into. I'm gonna give you all another minute. It is 12:07. We have another 10 minutes. All right. So I will show you a quick example. Okay. Of whatever we want to do. If any one of you wants to quickly come on stream and show it, for example, you Jackson. I know you already done a little bit of it ahead, which is awesome. So if you want to quickly come in and show, that's great. If not, I'll quickly show an example. So I'm going to give you all a minute to decide what you all want to do. If you all want to connect a specific component, or if you all just want to go with great question, Aptak. Ground basically is your negative lower voltage, or what I like to call the reference voltage. That's the voltage from that's the point from which you measure the voltage. Now the ground voltage, if you measure it, it might not always be zero, but that's where your voltage reading starts from. All right. You don't have to turn on the camera, Jackson, but I appreciate the thought again. Okay, I'm still waiting for you all to suggest components or something. If not, I'll run with a basic example. Anyone suggestions? NeoPixel ring does look complicated. You know what? Let's go for a simple, potentiometer input and a servo output. Okay. So what I'm gonna quickly do is I am going to add all the components first, of course, right? So I have potentiometer. We'll see if we want to blink an LED as well later. I'll leave it there. And LED is always good. I'm gonna go for a micro servo, I guess. We can also go for this. There's just different colors, I hope. Okay. I'll keep both of them just in case. And yeah, let's start connecting, right? So simple stuff we'll do first. Okay. What I will get is I'll also get a breadboard to connect everything together, right? So let's look for a breadboard. I think a tiny breadboard will work because this is too tiny. Let's go for a breadboard small. This is much better. In this, I can also show you how the whole power thing works as well, right? So you can see this plus minus already mentioned here. So I'll just go for that. So I'm going to connect one end to the minus, the negative end again to the minus. All the grounds I'm going to connect together. So ground, 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 ground. I was very lucky that I had all my wires in black this time. Next, I'm going to go ahead and connect all the VCCs, right? So I'm going to go ahead, take a red wire, go for a 5 volt, right? Connect it here. Next, connect all of my powers. So power, power, anode, great. So my LED will blink right away because I'm connecting it directly to the power. And what I haven't done is I haven't pulled a ground from the Arduino. So I will use this ground and connect it right here. If I could only make this neater. Hmm. We'll work on that a little later. Okay. So now all my pins are connected. Great. Now I need to connect my signals. So remember, servo is a analog output. So what I will connect to is maybe, what do you all think? Should I connect it to analog input, PWM pin, or digital output? Hi, Siner. Welcome back. I like the explanation you tried to give, Ian. Where do you all think I should connect the output of the server to, or rather the input of the server? Input into the server, but output from the Arduino. Great job. Eh, PWM it is. Right. So I will connect 1 2 D6. On a second thought, I'll just connect both of them to the same thing. So I'm going to take this wire, delete it, change the color for reference purposes. I'll let my servo colors be yellow. Take 9, put it here. Remember, these pins are shorted in the perpendicular to what we shorted earlier. Take the signal, connect it here. Take the signal from here as well. Let's move this a little down. There we go. Signal in the same line. Perfect. All my servos are in yellow and all the signal is connected to one PWM pin. Awesome. So let's start the simulation. Our LED should glow ideally. There we go. The LED is glowing and it's also about to burst. So we know that there's a maximum current going through it. All right. So what we will do is we can add a register later, but let's just do that while we're at it. So register. No, sorry. Resistor. My bad indeed. Mm, mm. Here we go. I'm going to change it back to red. Take it, connect it to power. And this I'm going to change it to for reference 6 against turquoise. Sounds good. Great. This will go into our input signal. So I'm going to use a random analog pin, right? So I'm going to change this position a little for it to be clearer. This wiper, I'm going to go to A2. A2 sounds good to me. Again, for reference 6, I'll change this to purple. All right. Great. So our connections are now ready. I'm going to give you all a minute if you all are trying to do the connections, and I'm going to start the simulation to see if my LED is not bursting anymore. Why is my LED not turning on? What did I do wrong? Oh, see, this is what I mean. This is what happens a lot of times when you're not careful. I connected this wrong. I connected it to the ground thing. That is how you debug. So there we go. This should work. So now it's lighting up. It's not very bright, but that's okay. It's just lighting up. So I'm going to give you all a minute to follow on with the. Thank you so much, Anisha. I wasn't watching the chat. Had I seen this earlier, this would have been easy. Thank you, A. Jackson. Thank you. So pin 9, Anish, because I am trying to connect it to any of the things that have a tilde on in front of it, right? So you see 9 is one of the tilde pins. You can connect it to 11, 10, 6, 5, 3. Over here, I randomly connect it to any pin that has A for analog input. Make sense, Anish? So it is random, but random with the tilde sign on it. Okay? Does that make sense, folks? Awesome. Great. So here's the thing. I'm going to quickly show you all how it would go around. How would you go around coding? The problem is this is block code. And I am not very fond of block code. So I'm going to see if there is text. Perfect. Text is amazing. I love text. Okay. So we're going to quickly go look at text. Anyone, any suggestions how it would work? So remember, there are some things that you need to do. Okay. So I'm going to quickly I have my code ready for the servo. So I'm going to quickly bring that in, right? And hope. So this is your basic code for digital LED, which I'm going to completely delete, right? There we go. And I'm going to add an servo. So I've got an include servo dot attach. This is a random number here again. We're doing 9. and these are basically your mapping numbers. Okay, so this is slightly different from the Arduino ID itself, but that's okay. We'll run with it. Okay. Next, what I want is my potentiometer code. So let's quickly get that in as well. If you all are doing it differently, do let me know. Sure, let me show you the circuit. You know what? I'll just leave the circuit on for like it's 12:17 already. Manya, if you're watching, I'm sorry. I'll just take maybe a little bit into your time. Okay, I'm gonna remove the code for a bit, and you all can see the circuit. Let me know, and until then I will just get all my code blocks ready as well. Okay, so up tak, let me know when you're done. That's all right. Okay, so take your time, let me know when you're ready. Are we ready, folks? Have you all made the circuit? If not, that's okay, take your time. Worst case, I'll put the code in later. You all can just run it, and I'll just explain the code to you right now. I'm trying to see this. Okay, if that instruction is for me, this thing, right? Circuit view, there you go. There, thank you so much. Yes, this is awesome, right? If you all want, I can share this later with you all. You know what? I'll just download it and I'll put it in Discord in case you all are trying to follow along. All right, there we go. So we have the circuit. Thank you, Jackson. Awesome. So I'll share the circuit later in Discord. Okay, so here's what I'm going to do. I'm going to quickly walk you through what the code will look like. And then later, maybe in the next 5 minutes, put the code into Discord and y'all can just copy and simulate it. What we're basically going to do is we're going to read the value of this, all right? Then we're going to write the value onto this by mapping it. Okay, so the only function you need to be concerned about is the mapping function, which is what I want to show you. So give me 1 second. Let me pull up the mapping function for y'all and it should be good. Basic. I don't know. Okay, code. Text. Continue. Alright, so how do you write the position to a server is you write server dot write. So I'm going to quickly open the code. Everyone's done with the circuit, right? So I'm just going to quickly go here, go into void loop. Mhm. I'm going to look first. There we go. So this is how you write. Okay, so we're going to now change the value of the position, right? So the how the mapping function works is you go map. All right. Now you know that the input is so first you're going to do position is equal to map, right? What are you mapping? You're mapping the sensor value. So you're going to do an int sensor value equal to the sensor value is over here basically the pin number. So what's your sensor value pin number? It's A2. So you're going to go ahead, put in A2 right here. All right. Then what we're going to do is we're going to do pin mode A2 is input. Oh, All right. And what we're also going to do is we're going to do pin. I don't think you need to do pin mode for the pin that you attach the servo to, but anyway, we'll see. Now I remember, so this is what you're going to do is you're going to map the position to the sensor value, right? So sensor value. Okay. Now we're going to do the low and low. So the sensor value low is 0. What's the highest of the sensor value? 1024. Remember? 23. My bad, right? That's your highest is 0 to 1023. What are you mapping it to? 0 to 180 degrees, right? So you're going to map it to anyone 0 to 180 degrees, right? So 0 to 180 degrees. Now, the only thing that could be different here is I need to do 0, 0 and 1023, 180, but we'll figure that out as we go, right? So, hmm, so where did I not declare it? We did declare it here, right? Ah, my bad. There we go. Alright, so this is the basic function that I wanted you all to have a look at to understand ADC, but now you all do. So what I'm gonna do is I'll quickly so your void loop is the main function, Zaim. Okay? So your main is the void loop. Alright? Awesome. So okay, so we're more than through with this. I'll put the exact code that you all can just pick up and paste if you all have connected it to the same pins with the schematic design on Discord. All right. Worst case, I'll put up a GitHub repo with everything. Okay, with all the PPTs as well. There's nothing in the PPTs except prompts, so you all can follow along. All right. Does that make sense, folks? This is the main function we want. I can't seem to stop this. Close. Still initializing, else I would have run it. But anyway, so this is a fairly simple. Okay, you all can definitely try around with this, and I'll send you the exact code in a bit. But I'm so glad you all could join. And again, feedback is very much welcome because this is a very new way that I've tried to do things. All right. And next, Manya is going to be here in the next 5 minutes if I go very quickly. And I'm sure she'll have an amazing session for you all. All right. But again, make sure that you do this. I would love to see pictures on Discord as usual once you're done, at least designing the circuit. And I'll be happy to send it to Mary for the next day stream. Awesome, folks. I shall see you very soon tomorrow for a completely different topic. We're going to be doing art with Python, and I can't wait for you all to try that. Bye, folks.